And quick diagnosis of a disease plays a very important role in the healing of the patient. If a disease is accurately diagnosed in the early stages, the recovery can be quick and would require less effort. Currently, we go to a doctor who diagnoses us based on our condition and what he can see. However, this method is not entirely accurate all the time, and misdiagnosis can be very problematic since the patient is given medicines which don't deal with his current situation, but in fact cause side effects as the disease they are supposed to deal with isn't present. This can lead to many problems, and the patient's health could get worse very fast. The statistics show that there are some select few diseases where the misdiagnosis rate is very high, or they are diagnosed but by then the diseases have advanced to a very dangerous stage. Mainly, you will see cancer is very difficult to detect. However, we will be focusing on Parkinson's disease, which itself has a high misdiagnosis rate. Out of every 4 Parkinson's patients, one was misdiagnosed. And out of the 26% misdiagnosed patients, 50% were given medication for a condition they didn't even have. 6% of those patients who were misdiagnosed even underwent operations and procedures. This caused a decline in health for 1 out of every 3 misdiagnosed patients. To understand how to solve the problem, we will first need to understand the current process of detecting Parkinson's disease. Parkinson's disease tests rely mainly on the L-DOPA test and a scan known as the MIBG scan and the DTII or dopamine transporter imaging inspection test. Both of these don't always give clearly interpretable results, due to which the patient has to go through these tests multiple times for a clear result to show up. And it is due to the inaccuracy of these tests that many times those with Parkinson's are misdiagnosed. In order to deal with this problem, we will create a machine learning model which will deal with the detection of Parkinson's disease. Now, there are some challenges we face with the current method of Parkinson's disease detection, which will have to be dealt with. Firstly, late realization of the disease being present. This can be dealt with by a machine learning algorithm which can use its powerful predictions to understand if the patient is in the early stages of the disease. Secondly, the process of diagnosing the disease isn't fast enough. It takes many visits to the doctor to detect the disease, and every time you have to make an appointment and sit at the clinic. This is not an efficient way to detect the disease. Thirdly, there is a high chance of misdiagnosis. 26% of patients are misdiagnosed. We need better accuracy because 74% accuracy is not good enough. And finally, the process requires the test to be taken many times for the doctor to be able to clearly understand the results of the test, of the L-DOPA test or the MIBG scan. So by the time, like, unless Parkinson's has reached a very advanced stage and is easily detectable, and by then it will be too late. Otherwise, it takes it takes a lot of retests to identify the Parkinson's disease. For creating our machine learning model, we will be using min-max scaler. Without scaling the values, variables with bigger values in them get a higher influence on our diagnosis. A variable with values like 2000 gets a higher influence when compared to a variable which max value has like 30, like, right? Like, a variable like years gets a higher influence than months. But in our medical case, we don't necessarily want that happening, as all the medical variables or tests or values are equally important, and they should all have an equal influence on our output variable or our predictions. Min-max scaler equalizes the influence of every variable on our predictions by converting all the values between 0 and 1 by dividing all the values by the maximum possible value. We will be using XGBoost, which is much faster and has a higher accuracy when compared to gradient boosting. Here I have mentioned how our model will be working. First, we will take the data, apply scaling on it before we split it into training and testing sets, 80% training, 20% testing. Then we will fit our model and get the accuracy. We are expecting an accuracy of 93 to 95%. And we'll be using binary cross entropy to get our error. The way min-max scaler differs from the other two main types of scaling, which are standard scaler and robust scaler, is standard scaler uses the mean and standard deviation to scale the values. Standard deviation is simply an average of how much the values differ from the mean, so the deviation, but standardized, so it's simply an average of how much the values differ from the average. This method works best for normally distributed data. Min-max scaler works better with data which has clearly defined high and low values, but it is susceptible to outlier problem. An outlier occurs when a data point is very different from the rest of the data. It is either way too high or way too low, but it is not normal and has very strange values. Min-max scaler cannot deal with this. For that you need robust scaler. Robust scaler renders outliers ineffective by only taking data from the 25th and 75th percentiles, but we are going ahead with min-max scaler. XGBoost is the best algorithm for dealing with small to medium structured tabular data. The way XGBoost works is that it trains several models like decision trees, random forests, and regression techniques together, runs them on the testing set, gets the accuracies for each, and then combines them to work together, where each model will give its prediction, and based on which prediction has more votes, the prediction is given based on which prediction has more votes. This improves the model accuracy, just like human beings. One person working alone may not be able to see all the details since he cannot be an expert on all the subjects. But several people working together with their combined expertise are better off since they can cover up each other's errors with their knowledge, and what one person will miss, the other person will definitely notice. Let's get to the programming part. We will be using Python and Jupyter Notebook to program our machine learning model which will detect Parkinson's disease. Data acquisition is always the first step to creating any machine learning model. We will import our necessary libraries and our data. Our libraries are NumPy, which is used for math, mean, median, mode, standard deviation; Pandas, which is used for handling our data, having a look at how our data is, getting the shape of the data. We'll be using min-max scaler, which we can import from sklearn, XGBoost, train test split, which will be for splitting our data in training and testing sets, and we'll also be taking our accuracy score to verify if our model is really as good as 93 to 95%. Here we are reading the data, so our data is stored in a CSV file, comma separated values file, where simply all the columns are separated with commas. Then we are taking the shape and head of our data frame. Shape simply means you're seeing the number of rows and columns in the data, and by head you're looking at how our data values are looking like, what are the individual values for every variable. Data pre-processing is simply where you prepare the data to be fed into the machine learning algorithm. So we are getting the list of features and labels. Features are our x variable, the one we will use to predict our y variable, which is the labels. Simply labels will tell you whether the person is suffering from Parkinson's disease or not, and features will be his several health reports and test values. Now we are implementing min-max scaler. We are giving min-max scaler -1, since we also have negative values in our features. And finally, we are splitting our data into a training set and a testing set. Our test size, as I've mentioned before, is 20%, and our train size is 80%. Model creation is where we are going to call and fit our model on our data. So model equals XGB classifier, and now we're just fitting our data on the training and testing sets. Then we will get the predictions, get the accuracy by comparing our predictions versus the actual values in the testing set, and multiply that by 100 since our value will come in decimals. So we want to see a clear value in terms of percentage. So in summary, we had some challenges and they have all been dealt with our model. Late realization of disease being present is dealt with by XGBoost classifier. The process is not fast enough as it takes multiple tests and visits to the doctor is solved by XGBoost. Higher chance of misdiagnosis 30% is also solved by XGBoost, which has a 95% accuracy, only 5% chance of misdiagnosis. And L-DOPA test for dopamine gives unclear results. This problem was solved as we take statistics of other tests and values to reach an accurate conclusion. So overall, there are still improvements we can make, right? We can try deep learning, which may help us achieve better accuracy, since a 5% chance of misdiagnosis is still a very large number compared to how many new cases of Parkinson's occur every year. But overall, this method has is very fast and has good accuracy.